All right, let's talk about something really cool today. It's a new AI from Meta called VJPA2. And no, this isn't just another language model. We're talking about an AI that's actually learning to understand the physical world. You know, developing the kind of common sense that you and I use every single day.
I mean, just think about this for a second. If someone tosses you their keys, you just catch them. You don't even think about it. But for a robot, that same simple act is incredibly difficult. We have AI that can master the most complex board games, that can write poetry, but when it comes to just interacting with the real world, understanding basic physics, knowing what's going to happen when you drop something, it's still a huge, huge challenge.
So what's the secret? Well, the answer lies in something our brains are doing all the time, completely under the hood. It's all about building an internal rulebook for how the world works.
Yeah, when that ball is flying through the air, your brain isn't crunching a bunch of complex physics equations. Nope. It's running a super quick, intuitive simulation based on a lifetime of just seeing stuff happen. You just know where that ball's going to go. That's our physical intuition, our common sense.
So researchers are trying to give AI that exact same superpower. It's called a world model. Think of it as an AI's internal learned understanding of its environment. And the key word there is learned. It figures out the rules by itself, just by observing, not by being spoon-fed a textbook. This lets it predict what might happen next and plan what to do.
And this is where Meta's approach, which they call JEPA, is such a game changer. See, a lot of other AI models try to learn by recreating an image pixel by perfect pixel. That's like trying to understand a forest by memorizing the exact position of every single leaf. It's crazy inefficient. JEPA does something much, much smarter.
And that smarter approach really comes to life in their latest model, VJPA2. It takes this whole world model idea and applies it to video in a really elegant and clever way.
This right here is the secret sauce. Instead of getting bogged down trying to predict every single pixel, VJPA2's goal is to predict an abstract representation of what's happening. It focuses on the gist, the meaning, the high-level concepts. It's way more efficient, and honestly, it's a lot closer to how we humans actually see and understand the world around us. So how does it learn? Well, you can think of it like a game of digital peekaboo. The AI is shown a video, but big chunks of the screen are just blacked out. Its job isn't to perfectly paint in what's missing. No, its job is to guess the abstract idea of what's going on behind those black boxes.
And the data totally proves that this method is the way to go. The researchers found this clear recipe for making the AI smarter. You start with your baseline, then you add more data, you make the model bigger, you train it for longer, and you use higher res video. With each step, the accuracy just goes up and up and up.
And when we talk about scaling up the data, we are talking about a massive scale. To build its basic world model, VJPA2 was pre-trained on over 1 million hours of video from the internet. It basically just binge-watched the web to get its fundamental understanding of physics and how things move.
Okay, so the AI can watch 1 million hours of video and get the gist of what's happening. That's pretty cool. But here's the really exciting part, the question that really matters. Can you take that general knowledge and apply it to a real-world physical robot? Can it actually do something?
For that, you need a specialized version. Meet VJEPA2 AC. That AC stands for action conditioned. This model doesn't just predict what will happen next, it can actually plan out a series of actions to make a specific goal happen.
Now get this. This is the part that's just wild. After that pre-training on 1 million hours of internet video, how much robot-specific interaction data did it need to learn how to do complex tasks? Less than 62 hours. That is unbelievably efficient. It just goes to show you that the general world model did all the heavy lifting. So let's actually watch it work. First, the robot sees the object. And using that internal world model, it's not just seeing pixels. It's basically imagining a bunch of possible futures and then planning the most efficient path to get to its target.
Next up is the most critical move, the grasp. Now, this is way more than just moving to a point in space. The AI has to understand the object's shape, the physics of gripping something, and based on its world model, it plans the exact, precise action it needs to pick it up.
And finally, success. The robot completes the pick-and-place task. This is the proof in the pudding, right here. The AI took its foundational common-sense understanding of the world and used it to translate what it saw directly into effective physical action.
So just how much of a difference does this make? Well, the numbers tell the whole story. On that full pick-and-place task, VJPA2 nailed it 65% of the time. The baseline model, the one without this powerful world model, just 10%. I mean, it's not even a competition. This is a massive leap forward for robotics.
So let's just zoom out for a minute. This is bigger than just one robot picking up one block. This research really points toward a future where AI learns in a much more general, much more efficient way, a way that's a lot more like how we learn.
So if you put it all together, what we're really seeing here is a fundamental shift. We've got an AI that learns by watching, not by being explicitly programmed. It builds its own internal common sense model of the world. That makes it incredibly efficient at learning brand new skills. And all of that is a huge step toward creating more general, more adaptable AI agents that can handle things they've never seen before.
And that really leaves us with a final, pretty big question to think about. We're building machines that don't just follow instructions anymore. They learn, they predict, and they act based on their own understanding of the physical world, an understanding they build all by themselves. What does that future even look like?